So let's talk about some rare events, the sample, decision, and conclusion. Okay, so suppose you make an assumption about a property of a population. This assumption is the null hypothesis. Then you gather sample data randomly. If the sample has properties that would be very unlikely to occur if the assumption is true, then you would make the assumption about the population is probably incorrect. So basically what we're doing with hypothesis testing is we're taking a sample and we're comparing it to the population. That's all that's going on. It's no more complicated than that. So remember that your assumption is just an assumption. It's not a fact and it may or may not be true, but your sample data is real and the data are showing you a fact that could contradict your assumption. So again, we do this in the real world. We look at populations and then we take samples to see if they're like the populations. Examples of rare events. For example, Didi and Ella are eating at a birthday party of a very wealthy friend. They hurry to be first in the line to grab a prize from a tall basket that they can't see inside because they will be blindfolded. There's 20 plastic bubbles in the basket, and Didi and Allie have been told that there's only one with a $100 bill. Didi is first person to reach in the basket and pull out a bubble. Her bubble contains $100. The probability of this happening is 1 over 200 or 0.005, which is really small. Because this is so unlikely, Allie is hoping that what the two of them is told is wrong and that there are more $100 bills in the basket. So a rare event has occurred where the first person got the $100, so Allie doubts the assumption that there's only $100 being in the basket. So basically what we're doing is you see something go on with a sample and you compare it to the population. They do this a lot in drug trials and different kinds of testing because they want you to see if your samples are like your populations. Why is that important? They do this a lot in drug testing because think about if you find a new drug and you've done testing on different groups or different samples, and one sample is showing really different information than the population, that could be a sign that the drug is really good, or that could be a sign the drug is really bad. So this is a way for statisticians to test stuff and make sure that we're not seeing trends that could fall outside the range of our population. So one thing we use a lot is called the p-value. So use the sample data to calculate the actual probability of getting the test results. It's called the p-value. The p-value is the probability that if the null hypothesis is true, the results from another randomly selected sample will be as extreme or more extreme as the results obtained from the given sample. Okay, so what I'm saying is I've got this sample and I want to see if another sample is an extreme. Okay, we say P is less than or equal to alpha, we reject the null hypothesis. So I'm saying the probability is less than or equal to the level of significance. We talked about that before. I reject my whole null hypothesis. The way I remember this is, and it's kind of crazy, but it might help you. People eat fish from the river Nile. People eat fish from the river Nile. And that's a way to quickly think about it. So a large p-value calculated from the data indicates that we should not reject the null, which means our null is good. The smaller the p-value, the more unlikely the outcome and the stronger the evidence is against the null hypothesis. We would reject the null hypothesis if the evidence is strongly against it. And like I said, smaller p-value, there's more evidence telling you that null is not good. All right, again, your decisions and your conclusions. So if p is less than or equal to your level of significance, you reject the null hypothesis. This means your null hypothesis is false and your alternative is true. If p is greater than the level of significance, you fail to reject your null hypothesis. That means that the null hypothesis is true and your alternative hypothesis is false. All right. So let's just talk about some just basic stuff about it. In a hypothesis test problem, you may see words such as the level of significance is 1%. The 1% is the preconceived or preset level of significance. The statistician setting up the hypothesis test selects the value of level of significance to use before collecting the sample data. Why is this important? So, my level of significance is how I'm fine tuning this test to see its relationship to the null hypothesis. A standard that we use in statistics is 0.05, or 5% is the level of significance. When you're dealing with people's lives, you might use a level of significance of like 0.00001 because you want to be very, very clear about what you're doing when you're dealing with people's lives and animals and things that, these are life or death decisions. When you calculate the p-value and you draw the picture, the p-value is the area in the left-tailed, right-tailed are split evenly between the two tails. For this reason, we call the hypothesis test left, right, or two-tailed. The alternative hypothesis tells you if the test is left, right, two-tailed. It is the key for conducting the appropriate test. Again, remember, the alternative will never contain an equal sign. Right, so let's think about the meaning of the p-value. A data analyst or anyone else should have more confidence that he made the correct decision to reject the null hypothesis with a small p-value. For example, again, 0.001 is opposed to 0.04, even if using the 0.05 level for alpha. Similarly, for a large p-value such as 0.40, as opposed to the p-value of 0.056, alpha equals 0.5 is less than either number, a data analyst should have more confidence that she made a correct decision in rejecting the null hypothesis. So basically what it's saying, and I said it in the first slide, is the smaller your level of significance, the more fine-tuned the analysis you're doing. Larger level of significance, you might not be testing on people or animal, and you just want to see if there's something generally going on. That's when you could use it. This makes the data analyst use judgment rather than applying mindless rules.